Is Airtel 4G fine for everybody, or do you see any differences these days? I'm using Vodafone. Or using anybody know, right?
There's a lot of network problems.
Exactly. I thought initially it's my phone. I'm just checking with multiple batches. That's what I'm hearing from everybody. And recently I heard that they had a lot of depth and all that. So maybe.
There's no proper network.
See, it's completely fluctuating. Okay. Okay, let's get started. Okay, so last time we were discussing, what is machine learning. Then we discussed what is supervised and unsupervised. Then let me proceed further to what is regression. So all the notes and the theoretical concepts can be found here. Okay, so introduction to machine learning, you can open this guy. Okay, so here supervised and unsupervised. Let me discuss now regression classification. Okay, so understand few aspects now. Okay, so everybody is clear what is machine learning, right? I mean the definition of it, the thing, what you're trying to do, you're trying to derive logic. If you ask me mathematically, okay, for example, you have, let me show you some data. You have, remember employee data we have seen, HR employee data. Okay, what does it consist of? It consists of satisfaction, all those things. Apart from that, it also consists of one more thing, that is your whether the employee will quit or not. Understood, right? So everything, suppose you want to predict if the employee will quit or not based on the other data. So your data becomes, everything about that particular employee becomes feature data. Okay, it's very important to understand the terminology, because going forward, this is not something you will be restricted to. You're reading books. Okay, that's the best way to learn a lot of things. So from if you start doing that, you'll find a lot of terminologies. Okay, sorry. Okay, I'll give you some example. What do you call? Just listen to this term. What is feature data? What is So we loaded this data, right, last time, HR data. So in HR data, you can see there are a lot of columns here. These are known as feature. Okay. lot of column. And if you ask syntactically, how do you write it mathematically? See, what is the thing that we wanted to predict here? This column left, whether the employee left the organization or not. Okay, this is what we call Y. Understood? Why? I mean, if you see, you know, all the notes of my, you know, machine learning documentation and all, this data will be called Y. And rest of the stuff is what? Rest of the stuff is about, you know, the employee, isn't it? That is called feature vector X. Okay, so the other thing is all called X, and this guy is called Y. Okay, and you can see these are all variables. These things are also known as variables. Okay, and this, how a user is represented at it is represented as a vector, feature vector. Understood? If I ask you what is the feature vector for user 0, what will you say? It is a vector of, how do you write a vector? You write a vector like this, right? You write a vector like this, right? Say in this data, 0.38 comma 0.53, 0.38 point comma 53, right? Although this becomes a vector, this is a feature vector. Each user data, you can understand these lines, each user data is represented as a feature vector. And this is, I mean, I'm just writing dot 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 for all the things. This is your X. Okay, and this is for one user. If you have multiple users, your other users will be represented like this. Understood, right? For different users. And the next thing that we have is Y. Y should be Y. What is the Y column here? Left or didn't dot, 1 or 0, isn't it? So it will be represented 1 comma 0. Like 1 was for this particular guy. Okay, 0 is for this guy, 1 is for this guy, and so on. Make sense? Okay, so a user details is feature vector. This is your X and that is your Y. Okay, now what do you do in machine learning? You just try to find the relationship between X and Y, right? Okay, if you are talking about supervised algorithms, supervised means you will be provided X and Y both. The feature data and target data both will be provided to you. It is, if it is unsupervised, you don't have idea of target data here. You don't have Y here. Okay, in that case, you will only have X, and you will try to find relationship between the data. Okay, and if you talk about regression means where Y is continuous in nature. For example, here you can see the value of Y is 1010 only, right? Left or didn't left, leave. This is discrete values of Y. That is why it is called classification. If, okay, classification means target is discrete. The output, that Y that you will be getting, that Y will be yes or no, that Y will be red, green or blue, that Y will be low, medium, high, right? This is discrete. Compared to this value can be continuous. For example, given a day's weather parameters, you are predicting the rainfall. That is 2.25, continuous. Understood what is classification, what is regression, and what is machine learning? What is supervised machine learning? Supervised machine learning is something, so you are trying to find the relationship between X and Y. And when Y is your continuous, you say it is regression. When Y is your discrete, you say it's classification. Clear? And what are you trying to do? You're trying to find relationship between X and Y. Now, some, we discussed hypothesis testing and all that thing, right? Okay, we connect these all to that. Okay, so now as far as so there are a lot of algorithms. Okay, these are known as lot of representation techniques. Like initially we'll start with linear regression, logistic regression. If you talk about classification, you have logistic regression, naive Bayes, decision tree, neural networks. A lot of them are there. Okay, these are known as representational technique. Okay, these are known as representational. These are techniques of representing y based on x. I mean, representing x such that you can get y. Right? These are representational technique. Now, okay, what you have to do? You have to find the best relationship between x and y. That is the ulterior motive. Okay, and what are the possibilities? What are the possibilities of relationship between x and y? It's very huge. If you want to understand the possibilities, let me give a simple example. Say for example, listen to these lines. It's a little difficult to understand. I'm going a little mathematical, I'll come up. You have 4 features. Okay, unlike in this case, you have 4 features. Value of each feature can be 0 and 1. Fine. Value of each feature can be 0 and 1. What is the possibility of total number of rows here, unique rows? No. You have each feature can be 0 and 1, and there are 4 options. So what are the total possibilities of features, possibilities of data? What is the data space? What is the total number of data that can be here?
12 times.
Huh?
12 times.
2 and times, right? So 2 raised to the power 4. Yes, 12 or? 12. Oh, no, not 12. 2 raised to the power n. Okay, 2 raised to the power n, with each value can be twice 0 and 1 binary, and there are 4 options. Right? That makes it 2 raised to the power n. Okay, so there are 2 raised to the power 4, 16 possibilities. Okay, of data. Now, 4 columns are there, huh? What is the so total there are 16 possibilities. Okay, 16 possibilities. And what you're trying to do, say you have 4 feature, right? 1, 2, 3, 4, 16 possibilities. This is your X data. Understood? You have Y data. And just assume it is the Y consists of only 0 and 1. Right? Y consists of 0 and 1 only. I mean, by class classification. Okay. What are the ways by which you can divide this 4 data into? I mean, 1 and 15, 2 and 13, 2 and 14. What is this combination? How many possible combinations are there? I mean, if you want to write down, just write down. So it will be 2 raised to the power 4. Okay, this is the possibilities. I mean, don't worry much. I mean, the idea is to just give you the impression that, you know, this is the number. What is this? 2 raised to the power 16. Just with 4 columns, where the value size is 0 and 1, you get 2 raised to the power 16 possibilities of separator. Like, what do you want to do in this case? As I mentioned, the data needs to be classified 0 or 1, right? So just imagine, you know, if you have a data like this, this is your x1, this is 1 column. Understood, right? This is x1, this is one column, and this is x2. Right? Just imagine again, each data is represented by a vector of 2 values. Okay, a vector of 2 values. I mean, 1 and 2 values, just 2 values. Each data is represented by 2 values, and you have y to predict. So you can plot that data in your in this 2-dimensional graph, isn't it? Can you? Like, you can plot all the data here. Like, say, just imagine you are plotting all the data here. Fine. You are also plotting the rest of the data here. what you have to do, you have to predict a relationship which will separate this data. And what you can predict this line, isn't it? Just theoretically, you can predict this line, and we can say that data in the left hand side of this line belongs to class 1, data in the right hand side of this line belongs to class 2. Okay, so the what thing that I'm asking you, what are the possibilities of this line? How many such lines are possible? Huge. That is where 2 raised to the power 16 comes into picture, right? For a simple data like this is, so you understood why I'm saying this. So you have huge possibilities of lines which can, hypothesis which can separate the data, right? What you have to do, you have to find the perfect relationship which separates the data to the best, right? That's the end goal. You have to find the best so each of these line is known as hypothesis. Hypothesis means what? Assumption, like a option that you are giving, like it's a thing you need to prove. It's an unproved theorem, right? You have a lot of these all are known as hypothesis. Okay, so and this 2 raised to the power 16 is known as hypothesis space. And what you have to do, you have to find the best hypothesis. If you just from this entire discussion, if you just got the sense that there is a lot of ways by which you can separate the data, okay, and this is one technique of separation. There are a lot of other techniques of separation. This is linear based separation, where you're drawing a line or a polynomial line and all that. There's the other based of separation, like which is based on trees, this tree based separation. There is a probability based separation. There are a lot of separation techniques. So among all those techniques, each technique has some configuration, so the number of possibilities are really huge. That is why when people come up with the question, how do you find out which algorithm is best? What are they asking? They are asking basically to find the best hypothesis from the hypothesis space. Got it, right? When people ask, you might have heard this line a lot of time. At least a lot of students ask me that how do you find the best algorithm? What they're trying to ask mathematically is, what is the best hypothesis among all the hypothesis space? I'm just connecting it mathematically because it's good to know. It's not that if you don't understand these things now, you won't be able to follow. What will happen after some time, when you understood rest of the things, you will be follow this back again. Okay, so don't worry. If you just get the sense out of it, get back to it. Okay, so now that's what we intend to do. So all these algorithms, what are all these algorithms? These are the different representational technique. This linear regression, logistic regression, this naive-based decision. There is a different representational technique. What you want to find out, the best representation technique. In that also, each representation technique, you will need different configurational parameters. There also you need to find out which configuration parameter is best for you. Right, so you have different techniques in scikit-learn which will help you doing so. These are known as grid search, pipelining. These are different techniques that we learn throughout. Okay, I think everyone got a sense of it, right? And can you give me some example of classification? Classification problems. Given a tumor data, it will predict whether it is cancer or not. Given a marketing campaign, given an ad, you want to predict whether somebody will click it or not click it. Given these are all classification. Regression can be, for example, given a house details, it will try to predict the price of the house. It will try to predict the price of the salary. It will try to predict the salary and many more. Got it, right? So these are so there are a lot of things that is mentioned here. Okay. And this is the entire process of machine learning. I mean, when you write a machine learning code. Okay. As of now, see, what I have done is I have taken the course more practical aspect. Okay, though theory is important, but I will be reducing it because we have limited time. But After you learn this practical aspect, I would encourage you to, read a book as well for the theoretical. Okay. The idea is to make the most out of the time. So this is the practical. I mean, if you say deployment aspect wise, this is what happens. Last time I was talking about data pipeline, right? Data pipeline, data cleaning, data processing, visualization. This is what we have learned so far. After that, we'll get into machine learning. In machine learning, we have both supervised and unsupervised. In supervised, you have all the options, regression, classification. In unsupervised, you have clustering and association. Association is the thing that we were discussing last time. People who bought this also bought this. This is like finding associative products. Okay. Then after that, training the model, validation and all that. Okay. I'll come back here and I'll take linear regression as an example to explain some of the concepts here. Understand few things. Okay, linear regression means linear regression is a technique. Regression technique. Regression means you're trying to predict output which is continuous or discrete. Continuous, right? You have feature data. So what will I do? I will create feature data. Okay, and I will try to. I'll try to. After creating the feature data, I will try to predict a relationship between feature data and target data. Okay, this is your X, this is your Y, right? X and Y. What you want to predict, right? You want to predict for a given X, it should be able to predict you Y. Okay, but you can see here the data contains a lot of information. So rather, I'll make it a little simpler. You have this sklearn is a library. Okay, and you have this data sets inside that you can generate a lot of data. You can make regression. You can see this will generate some regression data. If you want to generate multiple features, this is one feature, right? One column. Okay, if you see X now, X will have two columns. Understood? Okay, so you can use this utility to generate numbers and all that. I'll use much more simpler thing. I'll use this. I'll generate number insert with numpy. Okay, so with this example, I'll try to explain the process of machine learning. Okay, how does it happen? Pay a lot of attention here. Huh? X. That's okay. No need to code now. Just pay. Okay. You remember what is linspace? Okay, linspace means it will generate numbers between 1 to 1000 numbers between 1 to 10. Understood, right? Okay, it will generate 1000 numbers between X and Y. And what is your Y? 5 into X plus. Understood? Okay, so this is your X, this is your Y. Okay, now what we have, what is our feature data here, and how many columns does our feature data have? How many columns does our feature data have? One column, right? X is only feature data. X is as of now consists of only one column. How many column target data have? One column, right? Feature data one column, target data one column. And we, in this case, what are we doing? We are ourselves generating the data. Okay, we are telling the relationship ourselves here. This is X, this is Y, and Y is equal to 5X into plus 44. Fine. Now we will forget the relationship, and we will use this representational technique, linear regression here, to find the relationship. It is, if it is able to find the relationship. So for a given, for an unknown X, it can predict as Y. We will, this is a supervised algorithm. That means we will train it. We will train it with our data. So what will we do it? We will actually train it with, first all the data except for last 5 data. Understood, right? Except for last 5 data, we'll train it with everyone. Okay, if the algorithm is good, then for last 5 unseen data also it will predict you right results. Understood what I'm trying to say? So the first important thing is training the model. Okay, or using a representation technique to train it first. So that is the first thing that happens. So you have if for supervised algorithm, you have the data consists of your X and Y. You will train the model with this data X and Y such that it understands for a given X how to find Y. So, and after that you need to validate it. How will you validate it? By pushing in some unseen data. Okay. Okay. So let's first use one of the representational technique, and we'll learn this in detail from sklearn or linear model import linear regression. Fine. Okay. So this is the first regression representational technique that we are about to learn here. What are we doing here? First, create a. Okay. First, what you should do? You should create an empty logic. Okay. This is the so first create an instance of this. Then you should train it. And what is the data we will want to train it with? lr.fit. This is the training function. Fit. Train it with all the data except for last 5. Fine. Except for last 5 data. And you remember when you are training the data, see, as of now, important, if I do so, if I do this, I'll get all the data, but each data, as I mentioned earlier, each data of a particular each data should be represented in the form of a feature vector. Okay, feature vector, remember bracket, 1 data, 2 data, I wrote it. See, this data is not in that format, right? You have to convert it into feature vector format. That is where your reshaping thing comes into picture. Reshape. Understood now? The data is converted into feature vector now. This is your feature data. This is the target data. Feature data, target data. Now what is the thing that you need to do? You need to train it. Understood? The training is done. Okay, now what we expect this representational technique should find from its hypothesis space the best hypothesis, right? Okay, so let's see what is that it has found out. Okay, if I do lr dot predict. I should give it new data and should see, you know, if it is able to find that out, isn't it? This is the prediction, right? And we want to see the actual data also. Then prediction in the sense, this is the one that is predicting, not the new data. This data is unseen data. This guy has not seen it before. If it is able to find the relationship, what does it mean? That means, you know, this algorithm is capable of finding relationship between X and the data which is of type X and Y, isn't it? Bingo. And I took a very, very obvious, simple case. But with that, what you understand is few things. First, you have to, you have to train the model. Then you have to validate the model. Though I didn't do the complete validation steps, but I showed you something. Okay, this is the actual value that we are aware of, and this is the predicted value. And since these two guys are very close to each other, we say our a prediction function is good. That means whatever our linear regression has predicted for us, it's good. This is target data, right?
Yeah, my other target data is other is 5 only, right?
Last 5. Huh? You want to predict first, or you want to see the?
No, I just want to see. Actually, it was trained, right? Actually, it was trained.
Which one?
Y data, whatever we have, already we have the target data, right? So now we do this predicted now.
See, we knew this. See, to validate something, you need to know the good right results, and you need to predict the things. See, if you want to see if your son is doing good, okay, or your student is there, his copy needs to be checked out, you have to know the answer. You see what is the answer that he or she is giving. You try to compare between them. The more closer the answer is, the more accurate the numbers are. That's the theory, right? So here also you do the same thing. You know the results. These are the known results. This is what we generated long back. Okay, this is the results based on the prediction of this algorithm, this based on the relationship which it figured out. And what you're trying to do here, you're trying to find the relationship between this and this. Make sense? Target data is shaping, and this is API thing. Okay, target data is only one value, so it does not need shape. So what you try to did here? Okay, now let's dig a little bit more. I gave a superficial answer to a lot of things. What are you trying to do here? If you do you remember what was 5? Do you remember what is mx plus c? Y is equal to mx plus c. It is a straight lines equation. Okay, where m is the slope of the line, c is the intercept. Okay, if you ask me, suppose you have a line like this. Okay, and this is your x-axis. This is your y-axis. Fine. This is known as intercept. Okay, the point in the y-axis that the line is intercepting is known as intercept, and this is known as slope. The slantness of it. Okay, so what was, when we generated the data, what was our slope? The data that is 5x plus 44. This is the relationship between the line, right? 5x plus 44. So it actually calculated that coefficient. It calculated 5, though you didn't tell it anything. And if you want to see the intercept, see, pretty close. It is 244, right? Okay. So what is that you're trying to tell here? You actually, this was a hack here that we generated data which is kind of which actually, what was the relationship between in the data that was generated? That was a linear relationship, right? So we knew the data was linear relationship. We used this algorithm which is good in generating linear relationship, right? Okay, and it predicted for us. Okay, had it not been linear relationship, this algorithm would not work well. You might have used some other algorithm that is given decision trees and all that. Fine. So, and this algorithm is capable of predicting your slope and intercept both. Now, answer this question. How many possibilities of lines were there before it could conclude? For prediction. Yeah, I mean, we predicted one line whose slope is 5 and intercept is 44. Okay. So how many such possibilities were there? Exactly, infinite. Hugely infinite. And from there, actually, it found out the right one. Right? So now we'll discuss how does it do it. Understood? So the possibilities is known as hypothesis space. The chosen possibility is known as hypothesis. Okay. For a given representational technique, you will find the best hypothesis, and that's what you'll do it. Okay. Now, this is one line, say. Okay. This is another line, isn't it? This is another line. Okay, and just for this is your x, this is your y. Clear? X is your feature data, y is your target data, right? So, and let me draw some of the points. Understood? There are a lot of such points. These are the points. Means what? In the training data, this x is some value, y is some value, right? This cross means there is a data whose x value is this, whose y value is this. Understood? That is what it means. We are representing the data here. Now, okay, there is a thing of loss and concept. Okay, there are loss and cost. Two things you need to know here: loss and cost. What is loss? Loss. What is the act? Suppose you are predicting this line. Suppose you are predicting this line, this middle line. Okay. So what is loss? Loss is so if you are predicting this middle line, okay, for a given x, say for example, for a given this x, what would be, for example, for a given this x, okay, what would be your predicted y? If this is the x and this is the actual value, right, xy. So and this is suppose the predicted line, this line. Okay. So for a given x, what will be your y? For an equation like this. Okay. For an equation like this, so this is what it predicted, right? 5 coefficient into x plus 44.0, or just, for simplicity, just make it 44. Okay, for a given x, what is my x here? This is my x, right? Okay, for this particular value, if you have to predict y, what do you have to do? You write 5 into 9.96 plus 44. Understood? You have to pass this value of x so that you can predict y. Okay, you have to pass this value of x so that you can predict y. So that's what you'll do here. You'll pass this, you'll pass this value of X and we'll try to predict Y in this case. Okay, so that's what. So for a given, suppose this is the line that you have predicted, because your line is 5x plus 44. You have predicted this line, this ticked line. For a given X, what is, for example, this is the point. Or for example, this is the point. This is the point. What will be its Y, predicted Y? The point in the line, isn't it? It will fall in the line, right? For a given actual value is this. Okay, this is the actual value, but this point if will fall in this line, so actual predicted value will be this. Sorry. Okay, so this is the actual value, right? And this is the predicted value. Is it clear? Actual value, what is the difference between actual value and predicted value? Predicted value will fall on the line itself. Okay, predicted value will fall on the line itself. So the difference between the actual value and predicted value is known as loss. Is this point clear? The difference between the actual value and predicted value is known as loss. Okay, loss is with respect to 1 point. Okay, 1 point. Now, okay, so now what is loss? Loss is with respect to 1 point. Okay, 1 point. That means for a given point, this your actual predicted actual data is this Y, but a predicted data is this Y. So now what you do is you have to find the best line, right? So what you have to do is you have to find cost of each line. What we discussed about is loss of each point. Now cost of this line is the difference between this guy, predicted value and actual value, square of it. Okay, sum of it of all the points, all the training data, right? Sum of square of difference between predicted value and actual value. Okay, square root of it. This is known as cost of that line. Okay, so what is cost of a line? Cost of a line is RMSE. So square root of sum of squared of root means square actually. Okay, that is the sum. That is the cost of each line. RMSE. Understood? Sum of square of mean of, and then you do a square root. That is known as RMSE. You find that for each line. Which line will be the best? Mean means MIN. Which line will be the best?
The center line.
What will be the cost of a line which touches all the points? 0. What will be the cost of a line which touches all the points? 0. Isn't that the best line? Touches all the points. That is the best line, right? So there are a lot of other things why they are not best. Always welcome that. Okay, but yeah, till at this point of time, the logic says that is the best. So what is the idea? The cost should be minimum, right? Minimum cost means better line, less loss. Is it clear? So what do you have to find? You have to find what is this hypothesis doing here? Hypothesis training. It is trying to find the line with least cost. Understood, right? It is trying to find the line with least cost. Okay, that's the whole drill about. Okay, we are trying to find the line with least cost. Now, the question is, how do you find the line with least cost? You understood where we reached now from the beginning? Okay, now the question is, how do you find the line with least cost? Okay, because forget about all the possibilities. Suppose you are predicting a straight line. What is the possibilities of straight line? Really huge. Different value and different value of C, right? It has huge possibilities. How do you find the line with the best theta 0, theta 1? Theta 0, theta 1 is the coefficients. Like means M and C, right? You can talk to them about weights. These are weights of the line, or the M is your weight, C is your intercept, right? So you have to find the line which has least cost, isn't it? You have to find the line which have the least cost. Now, okay, there is a concept of gradient descent. Might go a little heavy now. Okay, there is a concept of gradient descent, which actually helps you finding the line with least cost. Okay, so let me explain gradient descent now. Is it clear so far? This is cost of the line. See, this is what I spoke, right? H theta x is your, if I have to show something mathematically, maybe I can, not leave an algebra. See here now. Okay, so this is what? Okay, so that's why if you see here also, everywhere they will use the term hypothesis and all that. That's the reason I used it, so that you find it really comfortable reading those. Okay, so this is the hypothesis that we have now. And this is the line of a straight line equation, right? Theta 0 is your intercept, theta 1 plus x, theta 1x. Theta 0 plus this is your intercept, and this is your prediction, isn't it? This is your prediction. Okay. Now, this was your loss function, isn't it? H theta x is your prediction. Okay, and yi is your actual data, right? Difference between them, you are squaring it. Okay, then you are summing it all. Then you are doing 1 by 2m, which is equivalent to root mean square error. Root mean. Okay. So what you have to do? Understood this formula? This is So sigma means sum of difference of square of all of them, and 1/2m is equivalent to doing a square root mathematically. Okay, because you know in older days there were no laptops, computers and all that. You still, this is invented like 60-70 years back, 100 years back. Okay, so see, things that we're studying now is 100 years old. Okay, so there you have to do all the maths manually by yourself. So that is why this was equivalent, which works out. And you, anyway, for you it doesn't matter what is the exact cost. For you what matters is what is the relative difference between the costs. Now here, okay, now here you know, this is j theta 0 theta 1 1/2m, and you have, this is the cost function, isn't it? Okay, now let's see. Okay, now what we have to do? We have to minimize the cost function, isn't it? Huh? And remember this line. What is the variable in the cost function? Your slope and intercept. That's the only thing that you can change, right? So that is the line. You have to minimize j theta 0 theta 1 is the cost function. Okay, and you have to minimize it by changing theta 0 theta 1. Understood this line? Right? What is j theta 0 theta 1? J theta 0 theta 1 is the cost function. This is clear, right? What is cost function? Cost function is for all the points. Remember this. Okay, and what you have to do here, this cost function h theta say has your theta 0 theta 1, right? Right. So what you have to do now, you have to minimize the cost function, isn't it? Okay, and by changing theta 0 theta 1 so that the cost comes very less. Okay, that's the thing you have to minimize. Now just see this graph. Just for simplicity, what it has done is it has removed when we have what we got rid of theta 0. So this is your cost. Did you notice this? This is theta 1. That means there is no intercept in the formula. Y is equal to mx. That's the only case. Right? And this is the cost function. This is the loss. I mean cost for each of for different theta. Is it clear? J theta is what? J theta is cost. This is different value of theta. For which the cost is this for. So which is the best cost? Huh?
The lowest one.
Lowest one, right? So that is one. At this point, the cost is least, isn't it? So what do you have to do? You have to find. You have the cost function. Remember cost function. Cost function. You have the equation of the graph. From that equation of the graph, you have to find. You have to find the point at which the slope is equal to 0. The point y slope equal to 0 because the slope at what is slope at this point? L, tangent to this point. What is slope of this point? This is the point that you have to figure it out, right? What is the slope of this point? A tangent to that point. What is the slope of a tangent which is parallel to x-axis? 0. 0. Okay. So that is what you have to find that point in this curve, in the cost function curve, at which the slope is equal to 0. That means d by dx of this. That's what differential equation is, right? The differential equation of this particular line is the slope at that particular point. So we have to find d by dx of the particular point where the slope is equal to 0. Is it clear? Right? You have to find that point at which the slope is equal to 0. Okay, so given a curve like this, we have to find a point, okay, here where the slope is equal to 0. That's the thing. Understood? From having a lot of possibilities of line, okay, to that these things are all happening. You don't have to do all this. Even if you don't understand now, that's okay, I would say. But if you understand now, that's great. Because my job is to provide details. Okay. But if you don't understand now, remember that you have to understand this at one point of time. Okay. Frankly speaking, when I was learning this, I didn't understand this in first shot. I understood this only after reading it again when I the entire thing was done. And more of these things got clear when I started actually discussing things. At work, it was very simple actually, simpler than learning it. Understood now? Okay, now let's see what is our end goal. Our end goal is for a given graph. Our end goal is to find the point at which the slope, at the lowest point of the curve, isn't it? Just imagine this is a curve. This is where you have theta 0 and theta 1 both. Right? You have theta 0 and theta 1 both. So what is the cost function here? J theta 0, theta 1. Right? So what is the point that you have to find here? You have to find the blue point, right? The darkest blue point. Okay. So you might start from somewhere. This is nothing but equation of a graph, isn't it? You have to somehow converge to the lowest point. Okay, you might start from here, but you have to converge to the lowest point. So this algorithm is known as gradient descent. What is gradient descent? For a when you have a loss from the loss function, it tries to find the point at which the slope is least or the slope is 0. Okay, so big gradient descent tries to find this point or this point. No, yeah, it will do one of them. Okay, see, if it is very similar to, if you are in the top of the hill. Okay, if you are in the top of the hill, you want to go down and it is all foggy. How do you go down? It's all foggy. You're in Chikmagalur Hills. Anybody been to Chikmagalur? You're not been to Chikmagalur? Should be. Okay, so you are in the top of the hill. It's very foggy. You can't see down. You still have to reach down because of some urgency. How do you do that? Huh? You want to reach alive. You basically, even if you are not saying this is what you do, you'll see nearby you and find the place which is steepest. You jump there. Again, from that point, you'll see which is the steepest point near it, jump there. Right? This is algorithm is known as gradient descent. Okay. I actually ordered a tab so that I can write it and show the maths here, but I will get it delivered tomorrow only. Okay. I'll show the maths. Now, okay, so what you have to do from this point, you have to find the next lower point. From this point, you have to find the next lower point and all that. Okay, so this is the new theta, right? Theta, this is the new theta. So what this is the cost function. This is the slope d by dx of this, right? And alpha is the learning rate. This is the jump size. I'm saying how long you are jumping. Understood, right? If you're taking smaller jumps, you might take longer time to reach to the bottom point. If you're taking longer jumps, you might skip the lower point. Understood, right? So this is known as alpha is known as learning rate. Okay, so
how do we predict which is the shortest for gradient descent?
From other possibilities, right? Yeah, we don't have to do that. This is what fit function does. But mathematically, if you have to do that, unfortunately, I still don't have that. But I'll show you the way I used to do earlier. I thought from this batch I'll start using that. I mailed you some links, right? Or I didn't do. No, I didn't do. Let's see if it is here or not. I just want to see if it is. So this is the cost function we already know, right? Let me see if it has done that. Because it is difficult to write that formula. That's it. Yeah, this guy has done it, so I can use his notes and I can explain it to you. Okay, just remember last time I was talking about d by dx power rule. What is d by dx of this guy? D by dx of x square?
Yes.
2x, right? Remember the power rule. Okay, now let's see. What you have to do, we have to find the, we have to do d by d theta. So we have to do two things, right? We have to find d by d theta of our cost function. We have to find d by d1 of our cost function. This you guys agree? We basically what we have to do, we have this slope and intercept, right? We have to minimize, we have to change the slope and change the intercept so that we can, that's what, right? You have to change theta 0, theta 1 and have to find the lowest cost. This point is clear. So what we want to do, we want to find how does my cost function changes when my theta 0 changes. What is the relationship between the change? That is your d by d. This is the cost function here, right? This is the cost function here, right? So, you know, if I am doing this d by d theta 0 of this cost function, what is it telling you? This is telling you if I change my d theta 0 will intercept. What is the impact in the cost? Okay, understood, right? And whatever is the impact, we'll try to negate the impact. Okay, so just see the maths here. 1 by 2m came outside. Right, 1 by 2m came outside, and this entire guy is here, right? So d by d theta, sigma also came outside. D by d theta of the entire whole square term is here. So what is the formula for whole square? 2x. And since remember this length in the inside, if you get it, it's okay. If you're not getting it, it's okay. It doesn't impact a lot now. Later on, anyway, we'll learn. Okay. So if it is d by d theta, this is the internal. Your x, I mean, this is like x square, so it is 2x, right? And do you remember that, you know, in case of you know, if the inside thing is also a function, you do d by dx of that also. Okay, that's what you're doing, d by dx of the inside thing. Okay, so this is what it becomes. What is d by dx of this inside thing? Okay, 2 into this. Okay, and d by dx of this entire thing will be is 1 actually, is not 1. If you expand it, what will it be? H theta x1 will be h theta x1 will be theta 0 plus theta 1 x1, isn't it? Let me see if it is done it here. He has done it here. Let me explain to you. So, okay. So h theta x1 is theta 0 plus theta 1 x. Is it clear? H theta x1 is the prediction, right? Prediction is equal to intercept plus slope x, right? So if you have this thing, so you can see, these things are all treated as constant, isn't it? Because when you are trying to do d by dx and you have something y based on partial differentiation, you always treat it as constant. So constant of d by dx, this all term goes away. The only thing that remains is this theta 0. That is why d by d theta 0 of theta 0 is 1. Understood, right? Okay, then if you try to do d by d theta 1, okay, and you have this, and here theta 1, it is xi, right? So the output is xi. Understood? So you have these two things here now. So the final picture becomes, yeah, that is what it is. The final picture d by d theta 0 of j theta 0 theta 1. This is the final outcome. Okay, this is the final outcome. If you continue doing, if you do this, okay, and you replace this by 1, right? It was 1, right? So g by d theta cost function, the outcome is this one, and that is why you have given here this one. And similarly, the other guy, if you x1, if you replace, you will get outcome as this one. So understood? This is the value here. Okay. Now, what will you do? He hasn't written anything beyond it. So this is the change that you have to do for theta 0. This is the change that you have to do for theta 1. You have two variables, theta 0, theta 1. You have to find how to reduce, how to increase theta 0 and theta 1 so that you get the lowest cost. And this is the change. So if you put this in, see here, if you put, see, this is the same thing. The new value, yeah, the new value of theta 0, right? The new value of theta 0, okay, is, this is the thing that we calculated right now, isn't it? Right? This is the thing that we calculated. So it will just change the theta 0 by that. It will change the theta 1 by that. And the objective is to minimize cost. Understood? How does gradient descent works?
So it's not equal to.
It will assign it. Polar equal to means whatever value will come, it will assign it to it. It's equal to 1. Okay, and that is how you will change theta 0 and theta. Let me just recap it. Okay, first thing, you found out the cost function. That everybody is clear, I guess, right? And did you understand the differentiation that I did here? Cost function. So d by, so what you have to do, you have to find how much change when you do this d by d theta of the cost function, what you are trying to find out, what is the relationship between theta 0 and the cost function, right? And if you found out the relationship, you'll reduce the you'll reduce the theta by that some quantity so that the cost function gets reduced. Similarly, you find the relationship between theta 1 and cost function, right? d by dx, doing a differentiation there. Okay, so that's what. So the new theta 0 will be that alpha is your learning rate, jump size, the degree with which you will be converging. Okay, and this is the change information. Is it clear? It is little difficult. It is little difficult. But if you get that idea, this is how it's doing. If you just read one more time, okay, I won't say that it is so easy to get in the first. Okay, but you should know when not everything can be like that. Not everything can be perceived in the first discussion. You have to read it. Okay. Anyway, this session is recorded. We'll upload this as well. So to listen to this multiple times, what I'm trying to say. So ask me if you have any difficulty.
We have to first. It doesn't work. So we have to pick out.
First time it is randomly initialized. After that, it will optimize it. Or you can make it 0, 0 also. This is known as gradient descent.
What is the alpha?
Alpha value, a good question here. Alpha value is known as learning rate. If you configure it too high, you might miss the local minima. What is local minima? Okay, if you are starting from this point, maybe this is the point you reach, lowest point. If you're starting from this point, you might reach this point. So this is the local minima, this is the local minima, these are two local minima. Okay, remember gradient descent may or might not return you local minima. I mean global minima. Global minima is the lowest point throughout. Okay, this is local minima, this is global minima. Don't worry, I mean the thing is it might seem little overwhelming. Huh?
We want global, not global.
No, we want global minima. Okay.
Why should we care about global?
Because if you can compare all the local minimas, then you can get the global minima, right? Understood, right?
So these things would be taken care of by the system itself. I mean,
you don't have to do. You don't have to do.
We should understand which algorithm we are going to take.
Right. Okay. You don't have to. Okay, so that's what, right? I mean, see, for any technology, there is some deeper concepts. Okay, so the same thing, I'll tell you my stories. I mean, when I was learning it long time back, these are the things. Initially, when you hear this thing, that is not clear. I was not able to connect a lot of dots. But when you finish a lot of things, then you think about it. That is why we did that. Okay, that is how it will happen. Don't worry about it. Okay, a few things you might have to take it with a pinch of salt. Okay, this is how it's happening. I might not get it, but you'll revisit it. Because as you see, it's not a straight line. Like if you're studying Java or Python, it's a straight line program. It's not like that. It's like a lot of connections are there, right? So you have to be a little patient, okay, and stick around. Okay, it's interesting. If you loved maths ever, okay, you can. If you sit behind it, you'll find, oh, this is how it is happening. It's interesting. Okay, so now.
The expression theta j is equal to assigning theta j minus something. Theta 0, theta 1. And I got a value alpha into something. I got a value, and I want to calculate theta 0. So I got a new theta 0. In the next step, I want to calculate new theta 1. In that, which theta 0 I have to say?
The new theta 0, right?
Or the old one.
You have to update in each step, theta 0 and theta 1.
No, you have to find the best combination of theta 0, theta 1. See, I think I.
Actually, during the first step, I have a new theta 0 and an old one.
So what your point? So you have to apply the new one every day.
Every time.
Okay, so whatever changes, I thought you were asking something else. Whatever changes, you can apply. Because you have to find for that combination of theta 0, theta 1, what is the lowest. Because that's the ideal good, right? You have to find the best combination of theta 0.
In the first value will be random one. First value initially.
It is generally initialized with some random values. Okay, or maybe something which fits in the range. That's all it is. Okay. Understood how it works? That is how it converges.
No, so alpha must be not be a very high value and not be low value.
Very low. Maybe somewhere 0.05 is a good alpha now. Alpha.
Between 0 and
0.04. Understood, right? So these are, how to find the best alpha? You do that using this guy, hyperparameter T. Yeah, you're saying something?
So we can
Down.
So
temp 0, which one is it?
They are using the old value.
This was the catch here. Come to the right hand side of both. So you have this. Yeah. So you have this temp 0 and temp 1. This is a new value. Then it is replacing it. Right. I take my words back. Okay. So yeah, this was one catch earlier. Okay. So what happens over there? Based on this value, you calculate the new temp 0. Okay. Then based on the previous cost function itself and previous value itself, you calculate temp 1 and then again you replace. Actually, it's effectively same thing because if you write it mathematically, right, it won't be impacting it because here it is a function here. It is calculating the cost, this value over here, whatever is the value, and it will replace. But yes, to put it in simple words, this is how it should be. It's replacing the same shot. Okay, but effectively when you do that also, right, it will not impact.
More accurately, we use that first time 0 in.
Which one?
We find that new theta 0, right? First we find that theta 0. Then we can put new theta 0 in the equation, second equation.
You put new theta 0 here. Actually, the value that is calculated here, and that is why I say that. Okay, the value that is calculated here is like pre-calculated for both of them in the first step. You won't be calculating this value again. Got it, right? That is why intuitively I said no, it doesn't matter because, but you have all before these lines executing this line, you would have already calculated these values. Understood, right? If you see gradient, you would have calculated. That's why. I was just remembering the code that time. In the code, you calculated both these values. You replace it over here, compound the new values. Okay, based on that, you again calculate this value. Okay, but I think what you guys were saying is right. Got it, right? So if you understood this and if you get time, I would highly encourage you to implement gradient descent by yourself. Implement linear regression using NumPy. Okay, I do that, but not in classroom courses actually, because it takes a lot of time if I go into these details. We do that specific to something. But I would highly encourage you to find a lot of references around it. Okay, just to get an idea around it. Okay, try to implement linear regression using NumPy assignment. Okay, good if you're able to do. Doesn't matter if you're not able to. You can do that. Try that. If you understood this point, that is the next thing to do. Okay, after that you realize that when you write in code, this is the only way you can write it. Okay, there is no other way you can write it. Okay. Yeah. One last thing before I proceed. Okay, so as of now, you saw me doing one thing. Whatever data was there, right? I divided the data into two parts. One part of the data used for training, one part of the data used for validation. Okay, this is how I will discuss next time what is bias, what is what is bias, what is variance, what is why did we do this thing, right? All these things we'll discuss. Okay, try to go through all these details that I discussed today. Okay, and let's see. Monday. Next class is on Monday.
Monday,
Friday. Friday. So yeah, the initial things takes a little longer time because I go little manually. As we proceed further, yeah, that's why we'll go through these things. Okay, I'm ending the session. Let's catch up. And I have uploaded the videos in visualization thing. Okay, go through the channel of visualization. I'll upload this also in linear regression. Ending the meeting. Any questions, Bhuvan, Kishan, Kumar, Vinay?
Antik, how frequent we use these functions, Antik? How frequent we use these functions? Like, as you said, like previously we used to, we will be updating data cleaning and data modeling. So, like, what is the level of experience? Like, which at what level people will use machine learning? Suppose, like, initially when we join in a job, no, initial days, one or two experience they will use machine learning, or it needs certain level. Like,
for some reason, your voice is not clear. I mean, none of us are able to follow you. Can you repeat it?
Okay, like what is the experience? What is the experience level we will use this machine learning concepts? Antik? Like, yeah, initially, like within suppose if I have 1 year, so I'll use machine learning concepts, or else it needs some experience, or like some designation wise, or how it will be.
So I'll put it simply that now in the job market it really does not matter. I mean, earlier, right, it used to be the case, if you're a fresher, if you know this much, this is sufficient. It's no more the situation. Okay, depends on the job, depends on the project, depends on your responsibility. There is no really guideline that if you're not this much experience, you'll not do that. I mean, nowadays you can see a lot of freshers from the college getting into startups, and they're doing data modeling and all that. So everything is possible. It's just about you getting that opportunity to do that. Okay, maybe in bigger organization it will take time, because there will be a lot of senior people who want to take good work, because that's what, right? I mean, they have to justify higher salaries. If there is some good work, they will try to absorb it. But in mid-level smaller companies, it is not the case. You anyway are overloaded with a lot of work. Okay, so that's the thing. Okay, but I think it's a wrong notion to understand that if you are lesser experienced, there will be lesser work given to you, or less difficult work given.
Not lesser work, like in some blocks initially, like machine learning, like the data scientists may work in like the data mugging and data wrangling things, but machine learning stuff, like it will be very rare to use something like that.
You might not do it, but during the interview they will ask you for sure.
Okay.
Okay, you may or might not do it. That is subject of a lot of things. But as far as interview is concerned, they will surely ask you if it's the data scientist.
Okay. Okay. Suppose if they will ask us like, okay, have you worked on machine learning? Like, what like how we have to react for that? Like.
So, though it is little I mean, we are in a premature stage to answer that. But as we proceed further, you will see we'll be doing projects. So that's what you'll say, that we started with the process of getting the data, consolidating the data pipeline, cleaning the data, visualizing it. Then we had a lot of hypotheses around it. We did a lot of hypothesis testing. We did grid search and all that. I mean, whatever journey we do, we'll learn, right? That is the thing that you have to tell to the stakeholders.
Okay.
Okay. Okay, guys. Have a nice time, nice weekend. Catch up on Monday.